we started with a project funded by Swiss National Science Foundation in 2006. It was the first phase of the project in which we were working with the calcine clays. But the approach was quite interesting because it was not only like pure clays everybody was using at that time, but also we were focused more on low-grade clays in order to disseminate to increase the availability of raw materials for this kind of pozzolan. Then the second phase it was the scientific outcome of the LC3 cement, the low carbon cement, we also investigate how could we increase the level of clinker substitution, not only using not only calcine clays, but also putting some additional source of calcium like limestone. And well, this is now we are in the phase of, as I told you before, dissemination of the results. So first we have a core. If you go back in time, we have a core of really fundamental science, and then slowly he have moved to more. You still have the core of fundamental science, but then you need to create the tools or to use the tools to disseminate these results in the industry. Well, Cuba is really expanding right now. It's a developing country, and there is a huge demand for cementitious material, both in the government sector, like building infrastructure in the country, but also in the private sector, like people building their own houses. So there is a huge increase on the demand of cement both for the people and from the government. And this kind of technology will allow to, with more or less the same clinker that is produced in the country currently, to increase the amount of cementitious material you can give to the people, because we are putting less clinker on the cementitious material in the binder. So it will allow to satisfy the demand for the population, and also at the same time we are keeping costs or maybe decreasing costs. This is still under study, and at the same time you feel okay because you are not you are lowering the environmental impact, which is also important, because we are a country that we are starting right now with this technology, and it will be very important for us in the beginning that we have a kind of clean technology. To make the path to development without keeping the environmental impact low. It has been a success because first, the only fact that we made the industrial trial, it means that the industry really support this project. In Cuba, because we were using a large facility, so they stopped the production for, I'd say, almost 1 month to make the production of this cement, and then it gave us the tools because one thing is when you design a product in the lab, and then you need to face which are the technological challenging of producing this cement. For example, for us, the first challenge was grinding. The first cement was not properly grounded, and then we have some issues at early age, but now we know how to solve it. So you need this kind of escalation. Also, we increase the social perception because we increase this cement. We don't keep it at the university. We give it to producers, both private producer or with the government producer, to use them and to have the feedback of how they feel with these products. And this is also important because it's help you as a scientist to have a feedback, but also it creates a social perception both in the industry or in the population. Okay, there is a new cement and it's working and these kind of things. Potentially could be huge because on one side you are tackling housing population in developing countries and many other countries. Not only there are a lot of people in the world that are lack of food or access to good water, but also shelter is a concern in this kind of countries. So you can tackle this kind of problem, but at the same time without compromising the environmental, I mean the earth environmental. So I think it's potentially good, but for this is because of that, is because of this phase of the project is so important. We know that we have the results, we have the studies, but we need to put that into implementation. So that's a critical point.